Take us to the pool with that party.
Oh yeah, or we can do them all.
All right. Another suggestion. Guys, what I want you to think about is that you look down that list of weight densities. What do you notice about the gasoline number?
It's bigger.
There's a range there.
There's a region there. Why?
Not all gasoline is created equal.
Concentration.
How many of you know? How many of you know that if you were to purchase gasoline, say on a morning when the temperature is about 30 degrees outside, that the gasoline is more dense than if you were to wait until an afternoon like this, which is approaching 80 degrees outside, where it's less dense? Do you realize that?
I read that it's supposed to buy gas when it's cooler, but I didn't know why.
Gasoline is very sensitive to temperature and its density. There's a reason its numbers have a region there, because it will fluctuate in its density based on temperature.
Are they supposed to like maintain temperature things so it doesn't change like that though?
Well, if they put it down in one of these underground tanks, it's going to be, relatively speaking, a constant temperature. But as it comes up the tube, it will fluctuate a little bit. I guess the theory is you get more or less. But what we are going to choose to do, if we have a problem that requires us to use the gasoline quantity, instead of creating a range of numbers, we are going to average them and use 42 for our calculation. Don't write it in the book, just remember. You have good memories.
Obviously not.
So that's what we're going to use. And just to understand that that one's different. Everything else has a single number. Now also in that section there is a formula. Right above that section.
WH.
Pressure equals W times H. What's W mean?
Wait density.
What does H mean?
Height.
Height. So as we are thinking about this thing, what we're going to want to consider is first, most of these items we're going to want to put into an X and Y axis system. So we have to identify where do I want to put the X axis, where do I want to put the Y axis. Yeah, but because this is in a plane, I can choose to put them anywhere I want to.
Put it at the bottom left corner.
Well, I could choose to make so that my X and Y axis are here.
That's convenient.
Okay. How about we not?
Let's do it.
Well, we could, but that's going to be quite a bit of mathematical work. And
Yeah.
because we're smarter than the average bear in here, we're going to make some choices. I could choose to put it right there.
Put it at the
I could also choose to put this right along that line.
left corner.
Let's go for the
And I could choose to split this one just like that.
Oh.
So that this point right here is 6, 0. And of course, this point right here is 0, 5. Why might I choose to do this?
Not really sure. I don't think it's a good idea.
You can find it first.
Remember, we want a depth, and we really need to know for that particular depth, this is a quantity that represents a depth representation, or a depth quantity. And I really need to know not just how deep this piece is, I also need to know how long is that piece. Now, if I choose to put the particular value of the axis right here, what have I done to my size left and right?
Cut it in half.
So I can really think about the value from 0 to 6, and then just double that,
Yeah.
because the left side matches.
Why wouldn't you just put it on the left side and it would just be 0 to 12, 0 to 9? Double it.
You could do either one. So we're going to do some calculations here. We're going to have a quantity that we call L of Y, which is a length calculation. For this problem, we're going to call it 6 because I'm only going to consider between here and here, and then I'm going to double. If we went from 0 to 12, the length would be 12. We're going to get to the same results. The second thing we need to discern is the depth, which is a height, or H of Y. And that's going to be back to our old friend top minus bottom, or top minus location. What is the position of the top?
5.
What is the location?
2.
How do you know?
1/2.
How do you know?
You don't, so I'm guessing.
What was there?
It's 1.
What was there?
It's 1.
What does it do?
It changes the P
So
value.
that means it's going to be,
X.
except that I'm working with Y's. The generator variable that we differentiate, right under it. So now I have to have a length, a depth, and some kind of a weight density quantity. If I put fresh water in this thing, what is my weight density now?
62.4.
I think pressure is equal to 62.4. And I derivative, 0.6. How many times am I going to do this?
Twice.
Double that size, times 2. The product of 6 times 5 minus y, dy. Does that look about right to you guys?
Looks like this
We're assuming that that's depth, right, going left and right.
This is your depth. This is your length. The length is then going to be represented with the differential y, differential things. That's going to be an area
The
calculation.
height is your depth.
Yes. So really, this is kind of a area concept here multiplied to a depth concept. So what do we do? Sure. Guess what that gives us? If I pull this constant 6 out of here, what did I find?
Whoa, whoa.
Wait a minute, why did I say 0.6? Sorry guys. Go back there needs to be mumbling about how that's supposed to be 5. It's the depth. Apologize. That's the depth. Not the length. It's the depth of that thing. 0 to 5. So there's my 12. 62.4. And I derivative from 0 to 5. 5 minus y dy. What do you do?
Take your-
Looks like 12 times 62.4.